First example. Write 54 as 9 times 6. Write a to the 7 as a to the 6 times a. Leave b to the 4. C cubed, c squared times c. Why? Because 3 times 3 comes out as 3. A to the 6 comes out as a cubed. B to the 4 comes out as b squared. C squared comes out as c. One element of a pair comes out as long as you have factors, multiplication. And you're left with 6ac. Second example. You have 32, which is 2 times 16, x to the negative 7, y cubed, 2x to the 3, y to the 5. You could subtract the 5 from the 3 in the numerator, or you can subtract the 3 from the 5 in the denominator. Either way, you have y over y, an extra y in the denominator, therefore y squared in the denominator. The 2 drops out. The x to the negative 7 is x to the positive 7 in the denominator. In the numerator, no, that's still in the denominator right here. So you have x cubed, you have x to the 7, which is x to the 10. So x to the 10, y squared in the denominator, x to the 5 times y. 16 in the numerator comes out as just 4. So 4 over x to the 5, y cubed. And then in example 3, we have 0.5 times this, which is when you multiply the 2.0625, which is 0.25 quantity squared, so 0.25 comes out. You have a to the 8, which becomes a to the 4 quantity squared, a to the 4 comes out. You have quantity squared. Now that minus sign does not turn the multiplication, the products, into a subtraction, because it's all this quantity that is squared. So this entire quantity comes out as power 1. But we want to guarantee that this is not negative, so we do absolute value. Sometimes authors say all the letters stand for positive numbers, then you don't need absolute value, unless a minus 7, even if a is a positive, let's say positive 2, this still comes out to be negative. Absolute values should really be in here. Although some authors are not very careful with that.